Good day. My name is Dr. Kirtley Thornton. I'm going to discuss today the use of the cognitive activation quantitative EEG approach to both the diagnosis of brain injury and improving cognition in the human brain with EEG biofeedback or neurotherapy as it is also known. Let's start with some basics. QEEG 101 gives an example of what the sensor is picking up from the ionic transfer in the tissue below, the gray matter. This is what a normal EEG will look like. We divide the waveforms into 5 different waveforms: delta 0 to 4, theta 4 to 8, alpha 8 to 13, beta 13 to 30 roughly, and gamma anything above 30. We look at communication patterns in terms of coherence and phase, location A and location B. If they have the same amplitude across the 1 second epoch period of time, that would be a high coherence value. The phase value between B and C represents the delay of the signal between the two locations. The shorter the time frame, the higher the phase value. Both of these are very important in cognition for both adults and children. Interestingly enough, the deficit in phase theta and alpha are seen in the learning disabled population along with excessive theta and delta, while in the brain injury situation there are decreased coherence and phase values. This shows you previous research results on the diagnosis of brain injury. From the impact test, the ED is the emergency department. The QEEG research is over on the right, and the blue line represents the initial discriminant accuracy, and then the cross-validation in the red. The research I have reported has gained the best overall predictive accuracy as well as the replication. These are the references for the previous slide. I was able to do this by looking particularly at the high frequency called gamma frequency, the 32 to 64 hertz. And here you can see in the phase and coherence of the beta 2 frequency the lowered values and the elevated values in the relative power of beta 2 in the frontal locations. There's a very strong effect which allows us to get the 100% accuracy. However, on cross-validation with a couple of new head injuries, we did not get the 100%, so I lowered the accuracy rate really to 99%, still very respectable. In terms of the treatment interventions, normally a 0.80 standard deviation effect is considered a very large effect. And we're seeing here on the far right the use of this cognitive activation approach, getting with auditory memory in the head injured subjects about 2.2 or 2.3 standard deviation effects, much better than all the other currently available interventions that are available in terms of cognitive rehab, strategies, computers, medications, etc. And the references for the previous slide. If you look at auditory memory effects, this is the standard deviation effect across the 4 groups. The gray in the middle for the traumatic brain injury represents the results of 3 studies with a fairly substantive sample size of 36. But you can see all the groups, all 4 groups, normal, TBI, adult and child specific learning disability, all showed significant improvements in the auditory memory. Were they better than normal after the treatment? Yes. All groups were substantially better than the normal reference group. So we compared the normal group that underwent the treatment to the normal group that had not undergone the treatment, and they were about 90% better on auditory memory. And this goes across all 4 groups again. They're all performing above their respective reference group. For the children, they use the child normal group as the reference group. Standard deviation effect size for reading, and again you can see a very substantive effect size across all four groups. Percent improvement in reading ability. All four groups showed substantive improvement in the red, auditory, and blue for the reading. So particularly impressive were the specific learning disabilities for adult children in terms of their percentage improvement on reading memory. Can we change the physical values of the quantitative EEG signal with operant conditioning? Operant conditioning has been around for decades, and the answer is yes. I'll show the evidence indicating that. This is a standard biofeedback session. Subject sits in front of the computer. The image on the screen reflects the value of the variable being addressed. These are the average changes across all groups on coherence values. Average about 6 to 7.5 on raw value, and about 1 to 2 standard deviations in terms of coherence alpha, coherence beta 1, and coherence beta 2. So the brain is very responsive to this intervention, this operant conditioning. Can we change the arousal levels? Yes. The value here on the far right, the beta 2 improvement, using confidence intervals and modern statistics, shows that we obtained a significant improvement in the relative power of beta 2. This is the case of a child who was hit with a baseball bat in his frontal lobes as a child. We get him about 4 or 5 years later. These wide swings in delta are very problematic from a cognitive viewpoint. We involve him in the treatment, do an evaluation 1 year later, and by and large, he's roughly normal. So it shows you quite visually that we can change the EEG signal. Conclusion: the QEEG is the most sensitive and accurate diagnostic test for brain injury that we have available. The activation QEEG database EEG biofeedback or neurotherapy is by far the most effective intervention we have available for the brain injured subject. Here's some information on the clinic where it's located in Charlotte, North Carolina, our website, neuroeducation.co, and our email and phone and fax numbers available. I encourage you to share this information with anybody you know may have a head injury, or any clinics nearby you involved in this type of treatment may not be aware of it at this point. Okay, thank you for your time and listening to this short lecture on the usefulness of the quantitative EEG in the diagnosis and rehabilitation of the brain injured subject.